Okay, so I'm going over last week's arrays test, and let me just get right into it. Number 2, you're supposed to create an array that stores the four numbers 2, 7, 1, 8 in that order, and these all work actually. Now, one important detail is that it didn't say you had to store like the array itself. So in other words, the first two do. The first one creates an array that stores 4 zeros, and then it replaces them with 2, 7, 1, 8. It succeeds. B does the same thing, just with less code. The last one creates a brand new array that stores 2, 7, 1, 8. It succeeds. It just then prints it, and it's temporary. It's gone once it's printed, but it still did successfully create that array. Number 3, you're supposed to have code that swaps two variables. And once again, you can either just run the code, and like here, temp would be 9, then A would be 2, and then B would be 9. So when you're done, A is 2 and B is 9, so it succeeds. Or just recognize the pattern. Whatever you got is on the right, so whatever you got copied here gets replaced in the next line. So what's in the right is then in the left, and then whatever's in the right is in the left. So that's fits the pattern. This one fails. This one, it works. The B on the right is now on the left, so once again what was copied here is replaced here. Then A is on the right, and then A is on the left. So 3 also fits the pattern. It also succeeds. Number 4, the variable C is just going to store the first char, then the next char, then the next char, and every step of the way you see that character printed with a space after it. Done. Now this one. First of all, recognize that this just swaps 2 elements, and really it's going to go through and swap like the first element with the last element, then the second element with the second last element, and the third with the third from last, and so forth. The thing is, you want to stop that process when you get to the halfway point, because at that point everything's been swapped. The whole array has been reversed. If you keep going, then it swaps everything back, and it's a fail. So that's why, like we normally would use B, but not in this case. We stop at the halfway point. Here, it's you just need to notice that the array got sorted. So people chose the A, but no, A is not correct. This one, there is no spot length. The last spot is spot length minus 1. And this is technically the error message you'd get in that case, array index out of bounds exception. Now, these you got to be careful with. First of all, let's be clear about what has next int means. Once again, it's going to start here. Has next int or return true, because you can turn a 3 into an int, and then this can be turned into an int. Notice what I'm saying: turn it into an int, because it's a string right now. So it'll take those characters and create an int from them. But you can't do that with 2.8. So when it gets here, has next int returns false. So that's it. It stops. Size is 2. So the array gets created at size 2. And it goes through again, and once again, has next int, says true when it sees the 3, true when it sees the 14, but false when it gets to the 2.18, so all you get copied is those two numbers, 3 and 14. Now, this next version fails because they used has next. Has next is going to return true as long as there's another token. So in other words, it's going to say, yes, there's another token, yes, there's another token, yes, and there's more data all the way through. So it's going to read them all and count them all, so the size will be 7. So it creates an array size 7. Then down here, it still uses has next, which once again is going to return true for everything. Whether the thing represents an integer or not even a number, this returns true. Which means it's going to return true when it gets to the 2.8, and the next int will try to turn the 2.8 into an int, and you get this error. And you should have known it was going to be an error, even if you weren't familiar with this exact error message. But the input is 2.8. It can't turn that into an int, hence the error message. Okay, here the return type is Boolean. It's a yes or no question. Does the array contain that value? And then you should be very clear about when you should return true, when you should return false. In this case, as soon as you find what you're looking for, you're done. You return true. So return true is inside the loop. Return false is after the loop. When people try to do this themselves, they try to do an if-else inside the loop, but you can't do that. So you can't return false unless you search the whole array. Now we're doing linear search. Very similar, except for now it returns where it found it, if it found it. So same structure. The difference is the return type is int, and then if it finds it, returns where it found it, I, in other words, and then if it goes through the whole thing and it never finds it, it returns -1 after the loop. Here it just averages. It should be obvious. It's a little different from other ways we've seen it. In other words, a lot of times we'll sum up ints, but then we'll need to typecast to make sure we're dividing doubles. But here, this already is a double, so we didn't need a typecast before the division. Now, that method did not say static in the header. It doesn't say public static double, which means it's an instance method or an object method. And so it's non-static, which means also that to call it, you need to create an object. You need to create an instance of the class and use that object reference to call the method. Once in static methods, you just name the class, like the math methods, but this was non-static. Now the merge method, it produces a new array that is both combined, so that's the return type, an array of ints. And then here, the key idea, once again, is that like we're going to put all the contents of these both in the new array. The contents of the first array go at the beginning, so that when we are copying, we're copying from the same spot, spot I to spot I. But then B, the contents of B go after that, and so you go from spot I in B to not the same spot I in the answer. You do A.length plus I. And so if A is 3 in length, then the first element from B will go into spot 3 in the answer. And then it'll go in spot 3, then spot 4, then spot 5, and so forth. Here, look, if you didn't recognize this, you should be able to run the code. And so, look, I'll run it on this example. So first it would store the 1. Then the loop would copy the 2 over the 1, then the 3 over the 2, then the 4 over the 3. Notice it's copying the element after the current spot into the current spot. So like I said, the thing in spot 1 gets copied into spot 0. The thing in spot 2 gets copied into spot 1, and so forth. And then when you're done, this temp was storing 1 in our example, and that goes into the last spot. And so the 1 goes over the 4 that was in the last spot, and there you go. That's rotating left 1 space. Here, once again, you have to get the right logic here. Notice big is storing the biggest, or the smallest number, I mean. Its goal is that it stores the biggest in the array when we're done, but we start out setting it to the smallest possible number, and then as we go through the array, if we find something bigger than we thought was the biggest, then we make that the biggest. Now, frankly, these all have the right logic. It was just how the arrays were set up was the difference. So here you just do a normal array access where I tells you what spot you're accessing. Here, once again, you don't do an array access because it's already been done for you. The elements get copied into item. Whereas this one is a mishmash. You're treating the number from the array as a spot to access, which you shouldn't do. Almost never should you do. You're probably going to get like an array index out of bounds exception. So that was the point of this question. Here, so we just want to sum up the contents. And the tricky thing about this was, like, number 1 was definitely the normal way we would do this. Number 2, it does the same thing. As in, it iterates through the array backwards, but who cares? The order didn't matter in this case because you just wanted the sum. They both work. Let me see. Here, it's the way the loop is set up is odd. It's abnormal. We normally start at spot 1, and if we used this code with that loop, then we would have skipped spot 0 and we would have gone out of bounds because of the equal sign. So B does not work, even though that's what we would normally do. Once again, if you're going to 1 and going to your equal to length, then you better use spot -1. Now, why do that? There's no good reason to do that, but you could. Here, once again, because it's static, we call it a class method. And because it's a class method, you would just do the name of the class dot get it to call the method. Like right here, you just do arrayHelper dot get it because it's a class method. Okay, here once again it's just knowing how to use the for each loop. And once again, value is going to be storing a number from the array. So you don't use it to access a spot in the array. That's already been done. It is a number from the array. And of course, you're counting odds, and so therefore you say the remainder is not 0. Now, this one, once again, you have to get the logic. If you want to know if they're in increasing order, but you're not checking that inside the loop. What you're checking is if you found something out of order. So if it's in increasing order, then the current element should be smaller than the one after it. And if it's not, well, then you return false immediately. But if it is, you need to just loop on, move to the next one. And you only return true if you found nothing out of order. So that's the logic here. All right, then we get to these. The first one, you're just copying count number of elements from arrays into an answer array that you then return, okay? And so like here, if this is my original array that stores all these values, and if I'm doing count 6, then I would just produce a new array of size 6 that stores those first 6 values. And that's pretty straightforward. This is all you need to do. Create a new array of the correct size, and then just loop through, and you're going from the same spot to the same spot, copying from the original into the new array, and then you return the new array. Done. This next one is much trickier because now you want to count that count number of values, except you want to exclude val. And so like in this example, if I say I want to copy the 6 values but not any of the 7s, then I would get the 8 but not the 7, then the 5s but not 7, and then the 0, 9, 1, 2, and I get those 6 values. The key thing to realize, of course, is that we're not copying from the same spot to the same spot necessarily. So you need more than one variable. In other words, you need a variable to keep track of where you are in the original array and where you are in the answer array. And so A was just wrong-headed. It treats it like the last problem, so it's a complete fail. B works, and the key thing to realize is, once again, I have 2 variables. One of them is just looping through the array. I starts at 0, goes as long as less in length, increments every time. So I is just keeping track of where we are in the original array. Remember, we need to stop when we've copied the right number of values. And so that's what this does. And so J starts at 0, and once it gets to be count, like 6, then we're done. And think of that. J would be 0, then 1, then 2, then 3, then 4, then 5. And then finally 6, which ends the loop. And you were guaranteed that there would be enough values, like you wouldn't go out of bounds. Now, I want you to look at this one, because this one was tempting. It iterates through every element of the original array, and we don't technically need to know where we're at in the original array. We just need to keep track of where it goes in the new array. So the problem here wasn't with the total setup, but just that there was nothing to make it stop once it copied the right number of elements. And so it could have been fixed just by putting this in the condition there. And so, you know, not just don't just check to see if the item should be copied, but make sure we haven't copied our quota yet. And then it would have actually worked. But this is the only one that works, actually. Okay, almost done. Now this one, the tricky thing was just frankly in the phrasing. And we've already talked about how to find the biggest and smallest. Once again, it starts, well, this part here is actually problematic. First of all, let me just focus on this part. Once again, if you want to find the minimum, you need to set that variable equal to the maximum possible value, and do the opposite if you want to find the biggest. Then as you go through, I would normally say, okay, small is going to be the smallest. If I find something in the array smaller, then I make small and store that. Or if I find something in the array bigger than I thought was the biggest, I make big, store that. The way this is written, it might seem kind of backwards, but you got to realize, like, you know, if I said 5 is greater than 4, that's equivalent to saying 4 is less than 5. And so, if this is written backwards from the way you would write it, then physically write it in the order you are comfortable with. And so that's what I'm saying. This code could have been rewritten like this, and then it matches the way I normally say it. that, okay, if I find something smaller than what I thought was the smallest, then I make small equal that. Or if I find something that is bigger than what I thought was the biggest, then I make big equal that. You just can't guarantee anyone is ever always going to write relations like this, greater than or less than statements, in the same order you would. So you need to know that to swap them. Now, and so the last one, it just has the symbols backwards. The first one had the symbols backwards and failed by just setting them both to 0. That's wrong-headed, and so that just won't work. And there you go. We are done.